Hi everyone, in this video we're going to be taking a closer look at the inbuilt sequencer programming menu for the PowerBox core and atom transmitters. Sequencers, what are they used for? If you're not familiar with sequencers, you probably haven't had an aircraft with landing gear and landing gear doors. We tend to use them on aircraft which have landing gear, and then usually if they've got landing gear doors as well, because basically you have to open the doors first before you deploy the landing gear, and then do the reverse when you retract the gear. In some cases there's some aircraft where the doors actually open, the gear deploys, the doors then close, and you fly like that or take off and land like that, and then when you retract the landing gear you've got to do the reverse. You basically open the doors again, you retract the gear, and then close the landing gear doors. In a lot of aircraft, fancy aircraft, you might find that the rear doors operate at different times to the front door, or the front gear operates at different time to the rear gear. And the sequencer allows us to control those functions. It basically allows you to step the servo through, or multiple servos through different points in time relative to other servos. So you can, for instance, you can move a servo a little bit, and then move another servo a little bit more, and then go back to the original servo, then move it back again, whatever. You'll see how that's done in the sequencer menu. Now, to keep things simple, I've only got one servo in this example to start with. I'll add a second servo a bit later in the video so you can see how you can add multiple servos. The inbuilt sequencer program handles up to 6 servo outputs. So basically 6 different servo controls, if you like. Obviously you can hook up multiple servos to that one output, but basically it's 6 individual outputs. So you can control 6 individual timing functions in effect relative to all the other 5 servos within that sequencer. And then of course you can have multiple sequencers as well. Okay, let's have a look inside the sequencer menu. Now to start with, there's not much there, so we got to add a sequencer. So hit the little plus sign there. You notice we've got a single sequencer there now. We can rename it just by clicking on there. You can rename it to whatever you like. Obviously, if you have multiple sequencers, you want to give them individual names. In this example, I'll just leave it as it is. The next thing we need to do is give it a control. Now, typically you use a switch. However, we have a lot more options than just a single switch. So we've got basic inputs. So you could use a throttle stick, rotary knob, slider, switch. We also have virtual switches, or our logic switches. The virtual switches, I tend to intermingle those two terms. So you could use a virtual switch, so you could use a combination of switches to trigger the sequencer. You could use a switch and a stick input. So there's quite a few options there. Then of course we have telemetry, so you could use a telemetry value using the telemetry control function. So a typical value from a sensor, whatever that may be, you could use that to trigger the actual sequencer. For this example, we're just going to use a basic switch. So I'm just going to use this top switch here, just to keep things simple. And I'll use the middle position as the on position, and if I pull it back towards me as the off position. So if I go to the next screen, it actually asks me where I want the off position and the on position. So I'm just going to drag these values down a bit to put the green zone in the middle there, because I want the middle switch position to trigger the sequencer. So that's the off position, and then middle position is on for this example, just to keep things fairly simple. Excuse my coughing throughout the video. And then you've got a mode, so you've got a single and a loop mode. So initially I'll keep it on single. So basically what that means is a sequencer runs in 2 directions. So you've got a forward and a backwards direction. Excuse me again. So basically when you flick the switch, the sequencer runs, say, in the forward direction, and then it'll stop. And then stay there. So basically that's good for, say, landing gear operations. So you could have, open the doors, landing gear doors, retract the gear, and then stay like that. And then when you flick your switch back, it does the reverse. So that's your single mode. Basically, it'll go in one direction and stop, and then it'll do the reverse direction when you flick the switch back. You can also have a loop mode. So the loop mode is handy for more so for animatronics. So if you've got like an animated pilot and you want to bobble his head around or wave, use his arm to wave backwards and forwards, you can put it into loop mode. So you can, add a sequencer with a loop function. And what that'll do is the sequencer will run all the way through to the end of the first sequence, so the forward position, and then it'll run through the backwards position and just keep repeating it. So that's really handy for those sort of applications. So typically for landing gear you just use single, but again for if you're using sort of animated characters or just trying to think of some other function, I can't really think of one off the top of my head, but typically you might have a fancy scale aircraft with a pilot waving his hands, moving his head and all that. You may want that to keep repeating itself, and that's where you'd use the loop function. Okay, moving along, we've got servos here. So let's have a look in there. Now there's a bit of a trick in here that people are unaware of. At the moment we're looking at a model which I haven't done any programming in, so this is a blank canvas model. So I've got all the servos, are not labelled or anything like that, so it's just got the default naming, servo 1 to 26. We're going to use servo 1. Now, when you select a servo here, just be aware that a sequencer will select a servo. Once you select a servo in the sequencer, you can't use that servo in your normal functions. So, and vice versa. If you're using already using a servo for a function, say your throttle, you can't then select it to be used in a sequencer. There's no option for that. So you can't sort of say, oh, I'm going to add a sequencer to my throttle, because it won't work. So just be aware of that. So you can only use like a free servo. So once it's assigned to the sequencer, it will stay assigned to that function being the sequencer. So like I said, if you've got a throttle servo or a rudder or aileron servo which is already assigned to those functions, you can't then come along here and select that particular servo to put into the sequencer. Can't really think of too many applications where you'd need to do that. There may be some out there, but typically when you have a sequencer, the servo is dedicated to that particular sequencer type role. Now in this case I can select from any servo only because like I said, this is a blank model, so I haven't sort of done any programming on it, but we'll just select servo 1. I do have a receiver, just a PBR9D receiver with 2 servos plugged into it, into channels 1 and 2. But we'll select channel 1, so this servo is plugged into channel 1 at the moment. And you'll notice now that I've selected it, it's moved a little bit on the offset. And you'll see why in a second. I'll just move around the camera a little bit and we'll go into the setup screen. So let's have a look at the setup screen. Now that we're actually in the actual setup screen for the sequencer, you'll notice there's 2 graphs, and if you look really carefully, the top one's labelled servo 1 forward and the bottom one's labelled servo 1 backwards. So basically what these 2 graphs show or highlight is the servo travel in one direction when we throw the sequencer or activate the sequencer, basically the forward direction. And then there's another graph for the other direction, or the backwards direction as far as the sequencer is concerned. So it gives us 2 graphs for the one servo movement. So that's important to remember later. So when you have multiple servos up here, you'll have multiple graphs for all these servos. And you may not want to watch or have too many graphs visible. You can deselect them from here up the top here. So at the moment I've got servo 1. We've only got 1 servo. Later on when we add a second servo, you'll see servo 2 appear here. And we can also deselect servo 2 at that point in time, or servo 1 from the screen. So depending on what you're programming and that, you might find you just want to look at 1 or 2 servos, and then move on to the other servos and program individually as far as their travel and endpoints and start-stop points are concerned. There's also forward-backward highlighting buttons, so you can turn off like the backwards graphs just by clicking that. So now we've only got the 1 graph showing the forward direction of the servo. We can turn off the forward one as well and just have the backwards one. Again, depends on how many servos you got selected, what you're actually looking at. So just be aware of that. And just a reminder, we can have up to 6 servo outputs per sequencer. Now, let's select the forward direction for this servo. So we've got this graph here. What's it showing us? So we've got a horizontal axis and a vertical axis. So the vertical axis is the easy one. Vertical axis is the travel for the servo. So when you fire up a sequencer, or the first time you go into it, you'll notice it gives you a default travel of negative and positive 20%. So the point on the far left-hand side here at the moment is set to negative 20%. If we then move over to the far right-hand side, we've got a point there that's at positive 20%. And you'll notice here there's a time figure as well of 6 seconds. So what that's going to do is basically run the servo from negative 20% to positive 20%, in other words 40% total travel, but takes 6 seconds to do that. As a matter of fact, if I just flick my switch, that's the backwards one, just ignore that for now. Let's run it. I'm just going to run it in the forward direction, so we'll see a green cursor. So the green cursor shows us the exact point in time along the graph. So this graph at the moment is from 0 to 6 seconds. And you can see the green line moving across, and then it stops. So remember we've got the sequencer set up for single mode, not loop mode. If it was loop mode, as soon as it gets to this point, it would then run this graph, go the other way, and then gets to there, it will then run back and just keep going round and round continuously until we turn the sequencer off. But in this case, we've only used single mode. So single mode runs in the forward direction and then stops. And then once we flick the switch back, it'll run in the backwards direction. So let's flick the switch back to my off position, if you like. And basically it runs through the bottom graph. Now these graphs can have multiple points. Now one of the first things I'm going to do, because 6 seconds is just taking way too long, I'm just going to reduce that to say 2 seconds. Now, you'll notice I've reduced it to 2 seconds. So you see here it says time 2 seconds, position 20%. So that's that point there that's highlighted in red. We can actually increase that point. Let's make it 100% to make the servo travel a bit more. And you notice the bottom graph though is still stretched out. And if we go to the bottom graph, if I select that, let's have a look at this endpoint here using the arrow keys. Notice that says 6 seconds. So this graph here is still set to 6 seconds. However, the top graph, the first point, if you like, that the sequencer stops at is actually 2 seconds. So when it runs in the forward direction, what that's basically saying is when this graph runs, or when we start the sequencer, the servo will start at negative 20% and then go to positive 100% travel, and it'll take 2 seconds to get there. And then basically it'll stop because there's no other points. And as a matter of fact, it'll wait for 6 seconds before the sequencer is actually technically stopped. When we flick the switch back, the servo will run from positive 100%. So this point here, if I highlight that graph and select that point, you notice it's at 100%, because basically that's our end point for the first direction. This point here has to be at the same point. So it'll start at positive 100%, and it will take 6 seconds to go to negative 20%, which is what that point's set to. So the main difference between the forward and backwards is really the time. So let's try that. Let's run the sequencer. I'll just run it backwards first. And you can see it's taking a long time or basically 6 seconds. Now let's go in the forward direction. Notice that's a lot quicker and the servo's moved a lot more. So again, if I turn it off, it'll run in the backwards mode or backwards graph. Simple as that. And you can see the actual time here as well. But what I'm going to do is I'm going to reduce the time here, and I want you to watch these two graphs. So this top graph shows 6 seconds on the horizontal axis, but our point's at 2 seconds. So remember that point was programmed for 2 second delay, or runtime I should say. And the bottom graph shows us the full 6 seconds because the points are set to 6 seconds time frame between each other. So these graphs always keep the maximum time you set a sequencer to. So just be aware of that. So one of them will scale. If you don't have, say, the forward running for the same amount of time, it'll scale the graph accordingly, which is what it's done there. So you notice there's a little 6 on the right-hand side of this graph. So you can imagine there, that's about a third of the way in, which is the 2-second point. And again, if you're not sure, all you need to do is touch the graph and highlight that point, and it'll give you the time in the little box there. Okay, so what I'm going to do, this backwards one, I'm going to reduce it. So watch what happens to this graph relative to this one when I reduce the time. So let's go to 4 seconds on the bottom graph. So what do you reckon the top graph will happen? Or what do you reckon the top graph will do? Let's have a look. There's 5, 4, and let's go a bit further, 3, 2. Now notice the bottom graph looked like it wasn't changing, but it actually is. There's a little number here in the left-hand corner. At the moment it's set to 4. So when I'm changing it here. So it's now 3 seconds. But as I'm changing the time on this graph is changing as well. So this point is moving because it's basically stretching it out because we're zooming in effect. So when we make the graphs the same, they both will appear with the same horizontal units, if you like, along on the x-axis, if that makes sense. So just be aware of that. And also, that can get a bit complex when you add multiple points. So let's make this point here negative 100% just to even things up a little bit, so you can see the servo move a bit. So at the moment, I've got a basic sequencer that runs 2 seconds in one direction, 2 seconds in the reverse direction, and the servo just basically goes from minus 100 to plus 100 and then back again. So there you go. Let's flick it back again. So that's backwards direction, forward direction. Again, you can see the green vertical line traveling on the screen. Now, say we're doing a bit of animatronics rather than just a straight landing gear or something like that, and you want the servo to do something funny in the middle of its travel. You don't want it to just go from minus 100 to plus 100. You might want to zigzag or whatever. How do we do that? We can add multiple points on the graph simply by selecting the graph. And then one thing to point out here is if you're on the end point, say on the far right hand side, which is basically the end of the sequence as far as the forward direction is concerned, you can't add a point to the end. You have to add it to a point that's previous to the end. So let's go to the first point, or the starting point, and let's click on Add. Now you notice it's put a point in the middle. So it's kept the end point at positive 100% travel, and it's added an extra point. Now let's move this point around. So you notice at the moment that one's highlighted, the middle point's highlighted. We've got 2 seconds of travel. We can change that, of course. The point at the moment is at the 1 second position, but let's say reduce it. Let's go to half a second. And let's change its travel. Let's make it, actually let's make it go the other way just so, no, actually I'll go the other way, go positive. I'll make it go to positive 100. Now I'm going to add another point, so click on OK. Let's add another point. And let's move this guy around as well. Doesn't really matter where we put him there, and I'm going to reduce the travel, or go in a negative direction. Let's go to 100%. So now we've got this sort of zigzag, bit of a zigzag graph happening as far as the sequencer is concerned. You'll notice the time though, the total time for the sequencer is still 2 seconds. Like I said, at any point in time we can change this. So you can make it, let's make it 3 seconds. But don't forget, if we go higher, so we go to 4 seconds, this bottom graph will change to match the 4 seconds of the top graph, and vice versa. So that's just a display thing. It's not altering the time of the sequencer in the backwards direction. It's just changing the graph. So it's just scaling the graph appropriately. Because what it does, the sequencer program or the menu keeps the graphs all at the same maximum time frame. So whatever graph is using, say, a maximum time of whatever it is, all the graphs will match that time. The keep things consistent basically. So in the forward direction, if we start off with this travel here, the servo will go from minus 100, positive 100, then back down, then slowly go back up to positive 100 again. So let's see what happens when I throw the switch. So I'll just throw it twice so it basically goes in the backwards phase. So this is where we normally would start from. So now flick the switch and it'll run in the forward direction. Watch the servo. So we've still got that same 2 seconds total sequencer travel. However, you notice the servo moves quite fast because it's trying to maintain all this travel within that 2 second time frame. So it's changed the speed of the servo to keep within the overall 2 seconds. So the sequencer is running for 2 seconds in the forward direction as a total. And basically it now has to travel faster because the servo is now going to travel more distance, if you like, because it's going backwards, forwards, and then forwards again. Or forwards, backwards, and forwards. But all within that 2 second time frame. Again, not too handy for landing gear applications, but where you have animatronics and you want a servo to move backwards and forwards or whatever, you know, there's that possibility. Now say you want this servo, say you had a second servo and you wanted this servo to move but then pause. How do we do that? Well, all you need to do is go into the graph. So say we want the servo to move from minus 100 to plus 100% within that time frame, but then we want it to pause a little bit. All you need to do is basically go to the next point and basically make the amplitude the same over that time distance. So let's go, oops, I just changed the time and not the amplitude. So let's go to positive 100. And then we can adjust the time to however much we want the servo to pause. And then let's, just to make it a bit more interesting, I'm going to add another point. And then just so we can see the effect of the pause. This point here, I'm going to make it negative 100. Okay, so now what will happen is the servo will run through. So if I click on OK, if I go back to the 0 time, and one other handy thing is as we adjust the points, as we highlight whatever point, the servo will travel to those points. That's really handy when you're setting up landing gear and flap doors and stuff like that. So we go to that point, and that's half a second from the start point. So within half a second, the servo will travel, providing the servo is capable of doing it, from minus 100 to plus 100. Then at that half a second point, it's going to sit there at that same travel position. So in other words, it's going to be paused for a bit of time, and then we can move across. So that's our 1.35 second mark. And then after that pause, it's going to go to negative 100% travel again within a short period of time, then back up to plus 100% travel, all within that 2 second time frame. So let's run it. So I'll run it in the backwards direction first to set it for normal working. Let's hit the forward go for the sequencer. So you notice the servo moved and then it paused, and you can watch it relative with the green vertical cursor. So it's pausing there and then it jumps again, zigzags again I should say. Now, one other thing I haven't pointed out with the sequencer is you can reverse the sequencer whenever you like. So say you start a sequence, so I can reverse it. A lot of sequencers in a lot of other radios don't allow you to do that. So in some cases that's really handy. So I can reverse it. So just be aware of that. Okay, so hopefully you're following it so far. Now what I might do is I might actually delete some of these points and add a second servo. So I go back to the standard plus or minus 100% travel within 2 seconds. So hopefully this has all been fairly self-explanatory so far. It's just when we start to add multiple servos it can get a bit confusing. So give me 2 seconds, I'll plug in an extra servo and we'll add it to the sequencer. Okay, we're back with a number 2 servo plugged into channel 2 on my receiver. Let's go back into the sequencer. So we're going to use the same sequencer. We're going to add the servo to it. So we're just going to go in here and add servo 2, simple as that. And you notice it moved a little bit. Obviously the position of the sequencers moved that servo. Now remember what I was saying about the servos up here. So you notice at the moment we've got servo 1, which is highlighted in blue, indicating that it's selected. However, servo 2 is not highlighted. So at the moment we've only got 2 graphs here. We've got a forward and backwards graph showing servo 1. However, if I highlight servo 2, apart from the scales have changed now, and I'll tell you why in a minute. So before I explain that, just remember that servo 1, because we're playing around with it, we'd set a maximum time of 0 to 2 seconds for both the forward and backwards directions. So the graphs for servo 1 show 0 to 2 seconds horizontal travel in both directions. However, the default for the sequencer when you add a servo and whatever is 6 seconds. So when we activate servo 2, these 2 graphs have rescaled and the horizontal axis is now shown from 0 to 6 seconds rather than 0 to 2 seconds. And that's all because we now have the servo 2 graphs in here as well. So now we have 4 graphs on our screen. We've got servo 1, forward and backwards, and servo 2, forward and backwards. As you can see, things can get complicated pretty quickly, so you've got to make sure you look at the labels carefully when you're setting it up. And like I said, you can deselect servo 1, so now we're just showing servo 2 if you don't want to confuse yourself. But the main thing is to remember that or remind yourself about the scaling factor. So if we go into here, these are the 2 servo 1 graphs. Let's see what happens when we change the scaling. If we make these, say, 2 seconds as well, so if I go to the correct point and make it the same as servo 1, so now these graphs for servo 2 are also highlighting the travel between 0 and 2 seconds in both directions. We now scroll up, you'll notice these graphs have gone back to the default 0 to 2 second scaling. Because the way this sequencer program works, it always uses the graph with the most time to display the overall graph, if you like. So whenever you change a graph's time, the graph with the most time will reflect the actual axis units, if you like, at that point in time, so to speak. So we now have 2 servos. Now remember, servo 2 is only traveling the default plus or minus 20%, as was servo 1 when we first went into the sequencer. And again, you can go in there and change it. No different how we did servo 1. So let's make it 100%. And let's make the other point minus 100%. And you'll notice we've now got 2 servos with exactly the same travels. Now, let's reset the sequencer, so I'll get it to travel in the backwards direction. Now, if I flick the switch, basically the servos will travel identical travels in the identical time. So nothing too special here. So just basically copied exactly the same graph between servo 1 and 2 in the forward and backwards direction. So let's make a sequencer where we're not going to worry about amplitude, because you can fiddle around with that. That's just straight travel adjustment. But let's fiddle around with the time. So let's make a sequencer. Say we want servo 1 to move first. So let's say servo 1, we want that to move from, say, I'll put them back in the start position, just so we have a better idea. Or let's make servo 2, sorry. We want servo 2 to move, say, to the mid position. So we're not going to go, actually I'll go full 100%. So we want servo 2 to move first. And then after servo 2 finishes its movement, we'll then get servo 1 to also move. And then when we flick the sequencer switch back in the opposite direction, they'll do the reverse. Servo 1 will move, and then servo 2 will move. So this is typically what you'd have for a very basic landing gear and door setup. So we want servo 2 to move first. So let's have a look at servo 2 graph. Let's get rid of servo 1. so I don't have to keep scrolling up and down. So this is the movement for servo 2. Now, at the moment, it's at minus 100% travel. So in the forward direction, we want it to go from minus 100 up to positive 100, which is over there and slightly out of view of the screen, but you get the picture, so to speak. And we want that to occur first. So we can just leave this graph as it is. So we're happy with the 2-second runtime. So it's going to take 2 seconds for this servo to move to positive 100. During that time, we don't want servo 1 to move. So basically, servo 1 has to stay at negative 100% for 2 seconds. So this is where we now go into the servo 1 graph. So we can scroll up to the forward runtime for servo 1. And it's already at negative 100%, so the servo hasn't moved. But we want it to stick there for 2 seconds. And we only want it to move after that 2 seconds. So let's add a point here. Now, let's reduce the travel of that point to negative 100%. So let's make the position negative 100. Now, this is the delay. So basically, during this time frame here, servo 1 is not doing anything. So the time will move. So the cursor will move along here. During that time, this guy's moving, servo 2. However, servo 1 won't do anything. It'll be stuck at minus 100% for that time frame. However, we want it to go out to 2 seconds. So originally our sequencer started with 2 seconds max. We're going to have to increase the sequencer time now, the overall time, because this is going to take 2 seconds to move. And then we're going to need another 2 seconds, say, for this guy to move from minus 100 to positive 100. So that's a total of 4 seconds. So let's increase, if I click on OK, let's go to the last point for servo 1. And let's increase the time out to 4 seconds. Now don't forget, when we do this, all the graphs are going to rescale on the x-axis. So they're now going to reflect 4 seconds. So again, servo 1 here in the forward direction. So this top graph, you'll notice if we go to that point again, you'll notice the point is actually at the 1 second mark, but we want it to pause for 2 seconds. So all we need to do is increase it to 2 seconds, just like that. So basically 2 seconds of runtime, servo 1 does nothing until it gets to the 2 second mark. So at the 2 second mark, this guy will be finished moving. Then at 2 seconds, he will start moving, he or she will start moving for another 2 seconds until it reaches positive 100% travel. So let's try it. Let's see what happens. So if I flick the switch forward, let's reset it first. Okay, ready, set, go. So we're happy for it, it's working correctly in the forward direction. So let's repeat that again. Notice servo 2 moves first, and then servo 1 moves. So that's how you add a delay. So basically you just keep this timeline horizontal at a fixed travel adjustment, and then you can pause it for however long you like, depending on what you want done. Now in the reverse direction, we want to do the opposite. We want servo 1 to actually move first. So when we flick it in the backwards direction, you want servo 1 to move first and then servo 2. So basically we're going to repeat the graph, but we're going to flip the servos in effect. So what I'm going to do is, just to clear up the screen a bit, I'm just going to remove the forward graphs. So we can only see the backward graph, so we can compare servo 1 and servo 2 right in front of us. So the top one is servo 1, bottom one is servo 2, only in the reverse direction. So our starting point for the reverse direction is on the far right hand side. So if I highlight servo 1, it's going to start at positive 100, because that's where, in the forward direction, that's where it's finished. But in the reverse direction, that's going to be our start point. And it's going to go to minus 100%. And it's going to take 2 seconds, which is what it's set to do at the moment. So notice our axis here shows 2 seconds. And that's because I've removed the forward graphs. So the forward graphs are running for 4 seconds. The reverse ones, or backwards, are running for 2 seconds. If I select forward now, the graphs rescale. So these are the same backward graphs for servos 1 and 2, but notice they've rescaled. So again, I'm highlighting this because that's important to remember, because people get confused when they're mucking around with times and stuff like that. So let's go back to just displaying the backwards graph for both servos. So as far as the top graph is concerned, I'm happy with servos 1's response. We're going to flick the switch, and the servo is just going to take 2 seconds to go to the negative 100% point, which is basically the start position. However, servo 2, I want it to delay it for 2 seconds at positive 100%. So this is exactly the same as what we did for servo 1 in the forward direction. However, this time it's going to be at positive 100%. So we're going to add a point, and we're going to make that positive 100%. And we're going to move, shift that point out for 2 seconds. Oops, wrong way. Oh, and I can't because I have to change the last point, because at the moment the last point's at 2 seconds, so it's not going to allow me to get to 2 seconds until I shift the point, the last point that is. So we'll drag that out to 4 seconds and go back to our middle point. Excuse my coughing. Had a cold the other day and trying to get rid of it. Okay, let's go to 2 seconds. So again, servo 2, we're going to flick the switch for the sequencer to run in the backwards direction. So the graph timing is going to start here. It's going to do nothing for 2 seconds. And then after 2 seconds, it's going to be here. It's then going to start moving, and it's going to take another 2 seconds to get to the final resting point. And as far as servos 1 is concerned, it's going to do nothing after its stop point in that graph. You don't have to add another horizontal line because it'll just sit there doing nothing. Okay, let's run it and see what happens. So remember, I'll just reset it. So let's run it now properly. So forward direction, servo 2 moves first, then servo 1. Now, let's see what happens in the reverse direction. Servo 1 should move, and then servo 2. So there goes servo 1, and there goes servo 2. Done. And if we had it on loop, basically it'll just, actually I'll just show you that. Let's go activate loop mode now. So just change it to loop, and we'll just go back in there so you can have a look at the graphs. You can have a look at all the graphs. If I scroll up a little bit, well, it probably doesn't really matter. So let's turn the sequencer on. So I've just turned it on, and basically there you go, there's loop mode. And like I said, of course, you can add another 4 servo outputs. So you can have some quite complicated setups. Obviously, you can have multiple points along these graphs. You're not stuck to 2 or 3 points. So you can have some complex movement or sequences in conjunction with other sequences as well. So you've got multiple sequences, you've got multiple points of travel, etc., etc. Again, you know, for a typical landing gear and doors, it's fairly simple setup. Don't have to go too crazy with the sequences. But when you get to, say, some of the animatronics, you can actually do some fancy stuff. Okay, hope you enjoyed the video. Any questions, just chuck them in the comments below, and I'll try and answer them if I know the answer. Thanks all for watching.